Good morning, everyone, and thank you, Aline, for this introduction, as well as Autodesk for sponsoring this event. So my name is Jonathan, and today I'm going to talk about the real side of XR. And by this I mean XR is a wonderful thing, and I'm sure lots of you already heard about what it can do. But this is the story about KPF trying to do XR and with all the challenges and opportunities that it presents. So I'm going to give you a very honest view on that. So KPF, for those who do not know us, we're a global firm, about over 600, 700 employees worldwide. We obviously build all over the planet, and we've completed 6 of the 11 tallest buildings in the world. And we also work in a wide range of different type of buildings. As for myself, I'm an architect, as Aline was explaining. I've got over 20 years of experience as an architect. I came across computational design whilst working on Stadium a while back, and ever since I've carried on doing more advanced geometries, more complex work. That pushed me to design technology in general when I joined KPF as a specialist. And that's also where, I've also, aside of that, always been fascinated by XR in general. Ever since the first Google Cardboard came out, that was it, I was hooked. And I think it's a fantastic thing. And, I also do lots of our research and development for KPF in that particular field. So today we're going to talk about the difference between VR and AR. Okay, XR is made of multiple things: VR, AR, and MR. And we're going to talk about what it means to implement XR to your office. What does it really take in terms of software, hardware, and also workflows? And also, what are the benefits and limitations? Okay. And finally, we have a very quick look about where XR might go. Okay. So, what's the difference between VR and AR? So VR is something where you are immersed. And that means the entire environment you're going to enter is completely designed by the design team, which consequently means you have a bit more work to do, right? VR can be done with a phone, can be done with a tablet. It doesn't necessarily need a headset. The very concept of VR is just that you're creating a virtual world into which you're going to visit, effectively. So it can be done with something very cheap, as we know with the Google Cardboard, etc. But to be fair, to have a proper VR experience, you probably need something much more advanced, such as a proper headset and setup. The kind of output of VR would be typically 360 panels, 360 tours, whereby you have a succession of panels that you visit, and you can look around. Real-time immersive experience or walkthrough, which is something we are doing at KPF. And then you have different options. You can teleport within that space. Teleport meaning you use the controller to move from one point to another, or you can actually walk. If you have a space that you defined, you can physically walk in that space, and that will effectively make you walk in the virtual environment. So these two technologies exist, and they are very different. AR is it's a different process. AR overlays the data on top of the real world. Okay, and what it's also doing in the process is enhancing the information. So what you see will come up with a lot more data than if you were just looking at it. You're looking at a building, you can imagine having information about the structure, about what's going on in that room, etc., etc. And what is also important is, yes, you can also do AR with a tablet, with a phone, for very cheap. There's lots of application out there that allows you to try it, to at least have an idea about what AR is about and doing. However, of course, if you want the proper experience, a real AR, MR immersive headset will make a huge, huge difference. So, what does it mean to actually do XR in the office? Super exciting, we want to do it, love it, but what does it mean? So, the first thing to understand is about any sort of a VR configuration is there are different ways to understand where you are in space, because you are moving into a virtual environment, but the system needs to understand where you are physically, okay, so that it can transfer back to the computer. So one of the first things to understand is the difference between what is outside in and inside out. So that's how the headsets communicates with the system to say, hey, you're looking right, you're looking left, you're looking up, you're looking down. And the system has to understand. If you are looking at an outside-in system, that's where you need basis, you need a tracking system in your room that actually feeds back to your headset to tell you what's going on. And that's a lot of gear, okay? The inside-out system means all the analysis, the scanning of the room is done by the headset itself. Much easier, much faster, smaller. Then you have the question of, is it wired? Is it wireless? Which is another big one. Typically, if you want higher quality, higher output, wired is usually the best solution because you don't have any issue with the Wi-Fi. You don't have to worry about bandwidth or anything like that. And of course, the advantage of wireless, however, is that you can take it off-site. It's much more convenient. You're walking in a room, you don't want to have your cable behind you. It's a bit cumbersome. So the two systems exist. Very important to know. A lot of headsets do both. That's another thing to remember. And then finally, you can also load the data straight to standalone systems. So for instance, if you have a Quest, or you can actually load your 360 panels directly into the headset, in which case you don't need a computer. You can just run it straight from the headset. That's also a possibility. Right. Now, that's the difference between carrying a outside-in versus an inside-out system. On the left, you have a Vario. And this would be the minimum amount of gear you would have to take with you to a client if you wanted to do the setup. Okay? On the right is the Pico, which is a standalone system that does the wireless. You can also cable it to your computer, but that's the difference in size and weight. So you can already see that they are two different things. So at KPF, we have a whole range of headsets. In fact, we have loads, even way more than those ones, but these are the ones we're currently using. The Quest 2, which you're probably familiar with. The Pico 4e, which is the enterprise version, very, very good headsets that we adopted recently. The Vario Aereo for very high realism. This one is tethered, wired, but very, very high res. And the Magic Leap 2 for augmented reality. Okay, these are, I would say, high-end headsets, the last two. Okay, and you can see some of them are inside out, some of them are outside in, and some of them have ability to do cloud streaming through the manufacturer, right? Not just through the software. So typical setup, if you wanted to walk, if you have a real-time walkthrough, this is what we do at KPF. We mark up the floor. This is your area. We will get a design team to come in there. And the two machines at the back are super power PC. They're very sharp, 490 cards, etc. The real deal. And why do we have to is because, as you can see, what happens when you do this kind of XR experience is people are waiting. They're waiting. They see what the guy is doing on the screen, but they're fundamentally waiting. So you want to make sure that as many people can do it as fast as possible. But it works really well, and designers and clients usually love it. Then you have a whole array of softwares that you can use and plugins. And this is great. I mean, there's a lot of them. Prospect, obviously, Autodesk products we use through Revit. It works extremely well. Archeo is another one that works with the Quest 2. Very interesting for collaborative work. You can also manipulate elements. It's a very, very nice thing. At the moment, the only thing is that it's mostly for the Quest. So that's one of the limitations of it. Sensio VR is effectively a 360 panel viewer with enhanced capacity. So you can create complete walkthrough with 360s, extremely good stuff. Worked with the Quest only at the moment, but hopefully more to come. Rhino, iRhino, really easy. If you work with Rhino, some of you are, that is incredible. It's just you can work it on a tablet, you can use a QR code to position your model, and it would do AR in seconds. It's extremely efficient and very cheap to run. Enscape, VR walkthrough, no problem. They also recently announced that they're going to do cloud VR streaming, so keep an eye on that. Very good. Twinmotion, again, that's a step up. Twinmotion, you can do more things, you can animate things, and it's also a fantastic gate towards Unreal. And Unreal is where you can start talking about AR. Okay, so you can see a chain of, different level of XR happening in here. Okay, and all of these softwares have a role to play at the moment in KPF. They're all used for different reasons, different level of realism, different level of interactivity with the software. Okay. Now that's an example of Prospect, which you might be familiar with. You can annotate, you can collaborate, you can measure, etc. All of these are very basic functions that you want from a VR experience. And but the realism is quite limited. Let's put it this way. Archeo is another one. What's great about it, you can use it on tablet, works really, really well. And you can see what it looks like through the tablet. It looks like it's on the table, and you can move around. It's a bit like iRhino, but you have loads and loads of functions in there. It's quite cheap to run really well on the Quest 2, standalone, so all of that, very, very good. Sensio VR, the one I mentioned earlier, you can get much higher realism because you're doing 360 panels, therefore you're not in real time, which means you can really push the resolution of your output. And that's what you would want. If you want something super real, that would be your best call at the moment. And you can create walkthroughs, so you move from one spot to another, from one 360 to another. Just an example of here playing with a time of day in VR in real time with Enscape, and here is Twinmotion. So that is a very good example of what teleportation is and how you can run this from a laptop. Okay, this is a powerful laptop. It's fitted with a A4000 NVIDIA, but you can see that it works extremely well, and you can literally navigate your model. And this is something the designers and the clients will want to do more and more and more. Okay, compared to an animation where you direct everything, you have a bit less work to do in an animation, but in VR walkthrough, you know, as long as everything is modeled, it's a fantastic experience. You're really, really experiencing the building at scale. Also great for visuals, of course, animation, super high realistic if you want to. It's a great software. And then that's the gate to Unreal. And this is what we've been doing recently at KPF. You can see here, this is seen through the glasses of the Magic Leap. And what it does, which is amazing, is you can see the difference between having an entire master plan laid out on a table. You can change the scale as much as you want. You can also create like a dollhouse, if you like, or you can put it all the way to 1:1. And if you put it to 1:1, that means you can do prototyping. It means you can take it off-site. You can actually show to the client exactly what's going to happen in the real life. You can even take that on-site in a construction site where you have your slabs, and you can create virtually what the apartment will look like, and you have the actual view. Okay, so all of these is absolutely mind-blowing, and it's really, really good. Works really well with Unreal, also with Omniverse, which is another guy. Okay, so a couple of things to do when you want to do AR, VR, etc. Remember that all the information that you push through means the system is going to get slower. So you want to make sure that you limit the size of your projects as much as possible. So you use boxing in Revit to do that. Also, make sure you check from the view you're exporting to using the Twinmotion exporter, which comes free now with Autodesk, right? Thank you, Autodesk. Also, make sure you can check the level of detail, because that will define how much information, how much mesh is going to come through, and that makes a big, big difference. So it's not just how you model, it's also how you export, which is very important. Then generally in the scene, try to remove any furniture that you don't need, any detail that you don't need, because all of this is going to make the experience slower, right, which we don't want. Make sure you check your settings. There are settings in both Twinmotion and Enscape, for instance. Most of the time, you do not want to use the maximum settings. You want to be around low to medium. Medium usually works fine. Sometimes high if you have a very powerful machine, but do not go too far, otherwise you're just going to have a very poor experience. But learn those settings. All right, and finally, this is the connection between our authoring software, such as Revit and Rhino, which are the main software we use to create our designs, and then all the various plugins that you can use, and then how these then connects to the hardware that I mentioned earlier. And you can see that gives you a full range of XR output and process. I put at the bottom Omniverse because it is currently working with Magic Leap 2, but it's, not completely official just yet. All right, so what are the challenges? Well, the first thing with VR is that it's very bulky. Okay, because you're immersive, it's quite bulky, and the other thing is it makes people very self-conscious. So be prepared that clients or even designers might find it a bit awkward to have a headset on their head, and it's a shame. If you worked really hard for a presentation and the client would not put it on, it's obviously a big waste and a risk. The other thing is motion sickness. And I know a lot of people think, well, it's nothing, it will go away. Well, actually, motion sickness from VR is extremely long-lasting. And there's about 25 to 40% of people that would be sick with VR. And that's because you can't see the horizon. That's because your body doesn't understand what's going on. It's losing tracks of the reality, okay? And it is a real issue, so just be aware of that. Not saying you shouldn't use it, but be prepared, is all I'm saying. So if you see someone not behaving well, take it off. make sure the frame rate is as high as you can. Again, this is linked to hardware, right? Resolution matters as well. Okay, if you then want higher-end real-time VR, which is what people are asking for today, you do need very beefy hardware. Be prepared to spend the money to get proper PCs, proper cable solution, etc., and good hardware, okay? The best you can afford. That will help with motion sickness, but it will also generally give a much more fluid experience, a much more real experience, and that's where you get the real benefit of VR. All right, AR, what are the challenges? Well, AR is very cool, but very expensive. The hardware is expensive. We're talking many, many thousands of pounds to get a good headset. It's not plug and play, really not plug and play. We are constantly in talking with the developers to make sure that it actually works. Every single update, there's a risk that it won't work. It happens to us a few times. But it's happening. It's happening, and when it works, it's brilliant. So personally, I think it's worth the risk. The other thing is, it's also more impressive. You can use with a tablet, no problem, but it's always going to be more impressive through the headset. So invest in the headsets if you can. Otherwise, you're only going to have half the experience. Okay? Right. So that's a quick review of all the various elements here. I'm not going to run through all of them, but generally, I would say VR is more affordable. Okay? You can start with very, very low value, low amount of money. You have the full control because it's VR. You have full control over your virtual environment, and in some cases, that's what you want to do. Okay, if the site is rubbish, you have some dirty things around. You might want to have full control. You might want to model everything to make sure it looks great. The blue sky vision. AR would not do that, but on the other hand, AR would have very interesting, very real context. There is a high risk of motion sickness in VR. We mentioned that. The virtual space needs to be modeled entirely, which means more time. Okay, be aware of this. And then you still need powerful hardware. VR streaming exists, but it's still very expensive. You have to pay a fee for that. It runs through subscriptions to get the good quality. And you also need to have a very good Wi-Fi. And that will be the same for AR, by the way. Whenever they have cloud streaming system, you are super dependent on your Wi-Fi. So that's something to keep in mind. 360 panels are awesome, but unless you make them super realistic, they're not going to wow anyone. Everyone's seen them before. The clients are used to it now. They're like, oh yeah, okay, right, I've seen that before. Right, move on. And they won't put the headset on because they know what they're going to see. So unless you make it super nice, forget it. If we go to AR, on the other hand, that's completely new. It's amazing. Everyone is super interested by it. Designers think it's absolutely fantastic to be able to change options, change the scale of your model just at a whim, basically. So very, very, very powerful impact on clients and the design team. But it remains extremely technical to set up. Be prepared. Very limited documentation as well, so you need to engage with the developers. It's almost impossible without that. And then you need to build up the skills. Unreal is very hard. Okay, Omniverse, very hard. You want to do that, you need to learn it. So again, be ready for that. And it is much more expensive than VR. Okay, that will be the last one. Okay, so when I mean be prepared, this is a typical example with Magic Leap 2. This is the kind of error message that you will get. On the right-hand side is things where you have to run into PowerShells to go start to put in a line of codes, etc., to get the thing to bypass Microsoft limitations. And I can't even start. It's just endless amount of issues that we run into. But when it works, it is amazing. Okay, so don't be put off by it. So why would we do it in-house is a question. There are loads of consultants that can offer this type of services. They will come to you. They will deal with all this, behind-the-scene nightmare, if you like, and they will do a fantastic job. And I think in some case, it's great. Of course, use a consultant. No reason why not. Especially if you don't have the budget to do it in-house, you might want to do that, and that's absolutely fine. But like for many things, like why would you do hard models in-house? Okay. Well, we do hard model in-house because we want to have control. It's all about design. It's all about making sure we get exactly what we want, what we're after, and that's what you get. So you're going to sweat on it, but you will be able to have multiple options. You'll be able to change things at the last minute. You'll be able to, get exactly what the design team wants. And this is such a such a technical thing to do that you really want to be there. You really want to have that sort of almost touch scenario. But it costs money. So that's the other thing. Just make sure you can afford it, because doing it halfway is not going to lead you anywhere. It's just going to die somewhere in the corner. So if you do it, make sure you're prepared to do it and get the proper budget for it. So how do we think XR is evolving? Right, the biggest one is this, VR streaming. Why? Because that will cut down the need for hardware. So typically what that means is, you know, the big PC that you saw earlier in the room, very expensive kit, all the tracking device and everything like that. If we were to go with streaming, and if the system is standalone, you don't need any of that. You can just use direct cloud-based rendering system to directly stream the VR information into your headset. So this is really what we're looking for. We're really, really keen to see that happening. At the moment, Vario is one of the only one that's proposing this to a very high level of quality. But I just mentioned Enscape as well, and I know for a fact that Unreal Twinmotion are also looking at doing that. Okay, so it's happening. That's good news, because it means it could be cheaper, could become cheaper to do VR and AR in your company. You might have to only, you know, spend the money on headsets, which is, you know, pretty significant saving. And you can take it off-site. That's the other very important thing. As long as you got a good Wi-Fi connected to it, you can go on site, do all of that, and have the full power of a good machine. So really excited by this. This is an example of what it looks like, right? So we did this test with Vario. The only thing to keep in mind, though, is that for this to work, you need to have an executable file. So in this instance, it's an Unreal file. That's like a game, if you like, that we made. And it's effectively running that piece of software. Okay? So it's a slightly different thing. It's not just about pushing it there. You actually have to do a bit more work. But the quality is very good. I mean, this is streamed through the Wi-Fi, and you don't lose any resolution. It's very smooth. You can do your walkabout, and the PC is not here. It's in the cloud. So the other advantage of cloud streaming is collaboration. It means you could have a client somewhere in Abu Dhabi or wherever in China, and you could say, okay, we're going to visit the building now. And you could use this level of realism to actually show what your design is. You could discuss it and do all of this without the need, again, for complicated hardware. Or you go to a client abroad, you use their Wi-Fi, and you do it there. You don't have to carry anything, just the headset. Okay, so extremely interesting tech. So the other aspect is the form factor. We talked about the fact that VR headsets are very bulky. Okay, and it's a problem. It is heavy. It's heavy on your head. Some of them are like half a kilo. It's just like, it's too much. Really, really heavy. And also some of them are wired. So this, by the way, all this was done with AI, just so you know, also a bit of AI there. What you can see here is that it will become lighter and lighter. And that is great, because the lighter it gets, the more people are going to be happy to put it on their head. It's less obstructive. You don't look like a clown. And you can, you know, walk around and have all the information you need. So this is already happening. You can already see literally a pair of sunglasses that actually do AR. Okay, so it's going to happen. It's going to carry on happening. And of course, Apple, everyone heard about it. The Vision Pro thing, the spatial computing, amazing. Well, they're very good at coining very cool naming, right? So they were not the first, of course. Magic Leap's already miles ahead. They've done fantastic work. But Apple the fact that they decided to invest in AR is very good news, because it means all the other manufacturers are going to do it as well. So we're very, very happy about that. We do think that the system will be amazing, although it is different to the Magic Leap, because you are into the mixed reality realm. They're using cameras to film reality to feed back to you. So you lose that actual real connection with the outside world through just glass, which the Magic Leap does. So be aware of that. It's also still a little bit bulky. So I'm looking for the next generation personally, but I think it's extremely good news that they're doing it, because you'll push everyone else to get better, lighter, faster, etc. And finally, for BIM, of course, we are here, and I'm sure there are lots of people around, digital twin, etc. It's the relationship between digital twin and XR, right? What's the point in doing incredible digital twins, full of data, okay, all the stuff that we put into our Revit models? What's the point in doing all of this if, in order to see it, you have to sit in front of a computer, turn on Revit, and then scan through the data? Why would you, clients don't do that. We had the talk, we did lots and lots of work. Clients are like, I'm not going to get Revit. I'm not going to get my computer and stuff. I don't even know how to run the thing. So that's where there's a convergence between AR and digital twins, which is obvious because you can then actually go in the real world, use your AR glasses, walk the building, and get all of this data fed to you when you want it. And that's really where the digital twins starts to make sense. You know, how do you use it in the real world? You go on the construction site, it's the same thing. You go with your AR, you have all the information you need, you know where to put X and X pieces of elements. So we are very much looking forward to have headsets that are lighter, easier to carry, can go off-site easily. And some people are already providing this, but we want this to become more, accessible, and that's so that we can do it in-house as well. And finally, all this beautiful data that we get in BIM will shine, and we'll finally be able to enjoy it and use it. And I'm going to finish with this. So there's been an evolution, right? We went from, obviously, being perfectly natural, being able to walk and see the world as we see it naturally, to being obsessed with looking at tablets and things and being very excited about it. And that's still something that you can do with AR and move your things around, and very bad for your back, just be aware. So thank God for AR, because we are going to be able to walk straight again and up again and see the world with a lot more information. So that's it. Thank you.